In this video, we will be looking at the CAPE Integrated Math 2021 Paper 2 exam. Alright, let's just jump into it straight away. So question 1. Represent the complex number z equal minus 4 minus 5i on the complex plane below. So we have the imaginary axis here that's indicated by im, and we have a real axis there that's indicated by r subscript e. So this would fall in the, notice both the real part and the imaginary part, both of them are negative, minus 4 minus 5i. So this would be in the third quadrant. So we're simply plotting the point minus 4 minus 5. So the real part is minus 4. And the imaginary represented here on the horizontal axis. And the imaginary part is minus 5. So this is the point. And of course we can use a ruler, of course, and we connect from the origin to the point. And that's the number represented on the organ plane. Alright, let's move on. If W equal Iz, for the Z given in A, and remember that Z, just recall, the Z in A was minus 4 minus 5i, that's what Z were at part A, and we're told that W is equal to Iz, represent W in the form x plus Iy. So W, we are told W is equal to I times Z. So that's I times Z, which is minus 4 minus 5i. So we expand the bracket. We end up with I times minus 4, that's minus 4i. And I times minus 5i, that's minus 5i squared. But remember that I square is equal to negative 1. So this is minus 4i minus 5 times I square, which is minus 1. So we substitute minus 1 for I square. So you'll end up with minus 4i, and then minus 5 times minus 1, that's positive 5. So let's put the real part here, the x, the real part here. So 5 minus 5 times minus 1, that's positive 5. And the imaginary part after, so that's minus 4i. So we move on to part B. The point A has coordinates minus 5, 1, that's A, and B, positive 3 and Q. The point M is the midpoint of a line segment AB and has coordinates P minus 7. Determine the values of the constants P and Q. Let's do like a sketch to represent the situation here. So we have a straight line. So this is meant to be a straight line. I use freehand, but really it's a straight line. You can use ruler to draw it. So A, we have the endpoints A and B. A is a point minus 5 and 1. And B is a point 3 and Q. And we are told that the midpoint M, so M is somewhere in the center of the line AB. The midpoint is P minus 7. So we are asked to find the values of P and Q. Now we know the formula for midpoint. The formula for midpoint is that if you add the 2x coordinate, midpoint is x1 plus x2. So the 2x values divided by 2, that's the x coordinate for the midpoint, and the y coordinate is add the 2 y values, endpoints, and we divide by 2. So let's call this x1, y1, and for b let's call it x2, y2. So the midpoint, notice we know the midpoint M. The midpoint M is P negative 7. So I'm going to replace M with P negative 7. M is P negative 7. And then, so this should be equal to, you add the 2x values for the endpoints, 3 plus negative 5. So 3 are negative 5 plus 3, add negative 5 plus 3. Divide by 2. And the y coordinate, what are the y values now? 1 and q, as positive 1 and q, divided by 2, we should get negative 7. So the P with this corresponding, the x coordinate here for the midpoint P, here P would be equal to negative 5 plus 3 divided by 2. That's equal to negative 1. And then here, over here now, negative 7. So P is negative 1. So the corresponding y coordinates now, negative 7 would be equal to 1 plus q over 2. What we can simply do is multiply both sides by 2 to solve for q. So I can multiply both sides by 2. So 2 times the right hand side, 2 times the left hand side, 2 times minus 7, that's minus 14. And 2 times 1 plus q over 2, that's 1 plus q. Alright, so that's 1 plus q. If we subtract 1 from both sides, we end up with minus 15 equal to q. So q equal negative 15. Next, we are asked to determine the equation of a line which is perpendicular to the line AB. So let's draw a line again. So we have a line AB. We have AB, and we found the midpoint M. The midpoint M here. So determine a line which is perpendicular to AB. So this is a perpendicular line, meaning this line this line meets AB at 90 degrees. All right, and passes through M. Give your answer in the form AX plus BY plus C equals 0, where A, B, and C are integers. So we want the equation of the perpendicular line. Now, to get the equation of the perpendicular line, we first need the gradient. Alright, let's remind ourselves what A was. A was minus 5, 1. So A was a point, A has coordinates minus 5, 1. And the coordinates for B were 3Q. Remember, Q is minus 15. So the coordinates for B would be positive 3 and then minus 15. And the coordinates for the midpoint is P minus 7, but remember P was negative 1, so the midpoint would have been minus 1 minus 7. So jumping all over the place. So this would be minus 1 minus 7. So we first need to get the equation for the perpendicular line here to AB. We need the gradient of AB. So the gradient of AB, remember the gradient, can use the formula y2 minus y1 over x2 minus x1. Remember, we had called this x1 y1, and we had called this x2 y2. So the gradient of AB would be y2 minus y1, so minus 15 minus 1 over 3 minus 5, right? So 3 minus 5. So this will end up with minus 16 over 3 plus 5, that's 8. That's minus 2, or I could say minus 2 over 1, which means therefore the gradient of the perpendicular line to AB would be the negative reciprocal of whatever the gradient for AB is. So the gradient for AB is negative 2 over 1. So for the perpendicular line, it would be the negative reciprocal. That's half. Remember, the product of the two lines, the two gradients, should give us negative 1. So this is what we'll be using for M. So the equation now. So equation for the perpendicular line, and of course it's a perpendicular bisector. Notice this line, it's perpendicular to AB, it also bisects AB since it passes through the midpoint. So we can call it the perpendicular bisector. So equation for the perpendicular bisector of AB. Alright, we found the gradient to be half, right? So we use the formula. Let's use the formula. M equal to y minus y1 over x minus x1. Or we're going to use the point that the line passes through, which is a midpoint, minus 1, minus 7. So m, that's half. So it's y minus, this is the x coordinate, it's the y coordinate. So it's y minus 7, so it's end up become y plus 7 over x minus 1 becomes x plus 1. Alright, so what we can do now is we can just cross 2 times y, it's 2y, and 2 times 7, that's 14, equal to 1 times x plus 1, that's x plus 1. Now remember the question wants us to write the answer in the form where we have everything on the left hand side. Alright, so we just group everything on the left hand side. So we end up with 2y minus x, and if we subtract 1 from both sides, over here we end up with 14 minus 1, that's 13. So 0 on the other side. So that's the equation of the perpendicular bisector to AB. So now we are at part C. Given the matrix is A, we are given some terms here in A and B. Simplify the elements of the matrix A, leaving the values in third form where necessary. So A, let's write down the coordinates. So A are 4 sine pi over 6. Now pi over 6 is the equivalent of 30 degrees in the radians, in 30 degrees. So pi over 6, so pi over 6 is in radians, convert that to degrees, that's 30. So 4 sine 30, if your calculator is in degree mode, sine 30 is a half, so 4 times that is 2. Sine pi over 2 is equivalent of 90 degrees, sine 90 is 1. Pi over 3 is equivalent of 60 degrees, because 60 is half, 2 times half is 1. And then pi over 6, that's 30 degrees, so cos 30 is root 3 over 2 times 2, so that's root 3. Alright, so that's A, simplified. And then we're asked now to calculate the product AB. So AB is A times B, so AB would be equal to A, which is 2, 1, 1 root 3 times B. Let's remind ourselves of what the matrix B is. B is what? 4, 5, negative 1. So 4, 5, negative 1. And 5, 4, 0. 5, 4, 0. So notice we have for A is a 2 by 2 matrix. B is a what? That's 2 rows, 3 columns. So B is a 2 by 3. So when we work this out, we should end up with a 2 by 3 matrix. Alright? Let's do the multiplications now. So row by column. So we apply the first row to the first column. So 2, 1. We apply that to 4, 5. So that's 2 times 4 plus 1 times 5. Then we apply 2, 1 to 5, 4. So that's 2 times 5 plus 1 times 4. Then we apply the same row 2, 1 to negative 1, 0. So that's 2 times minus 1 plus 1 times 0. And then we apply 1 root 3, the second row now to the same 3 columns over here. So 1 times 4. So 1 and root 3 to 4, 5. So that's 1 times 4 plus root 3 times 5. And we apply the same 1 root 3 to 5, 4. That's 1 times 5 plus root 3 times 4. And we apply 1 root 3 also to minus 1, 0. That's 1 times minus 1 plus root 3 times 0. So we can simplify. We end up with what now? So we end up with, let's see what we end up with here. So we end up with, so 2 times 4, that's 8, 8 and 5, that's 13. 13 next. 2 times 5, 10. 10 and 4, that's 14. And then 2 times minus 1, that's minus 2. And 0, that's minus 2. The bottom row now, we have 1 times 4 plus 5 root 3. So 4 plus 4 plus, I think I need more room, so that's 4 plus 5 root 3. And then the second element here in the final row, that's 5 plus 4 root 3. So we're actually leaving unsigned surds. And then this is just negative 1. Root 3 times 0 is 0. Let's move on to part D. A polynomial. We are given a polynomial there. We are told it has a remainder of 108 when divided by x minus 4. So let's pause here. So we have a remainder of 108 when divided by x minus 4, which means that, well, p of 4 should give us 108 based on the remainder theorem. Also, we get a remainder of negative 100 when we divide by x plus 4, which means that p of negative 4 should give us the remainder, which is negative 100. So we should end up with a pair of simultaneous equations here. Alright, so p of 4, the first one, p of 4, should give us the remainder of 108. So p of 4, we replace x with 4. So 2 times 4, x cubed, that become 2 times 4 cubed, plus a times 4 square, replacing x with 4, plus, replace x with 4, that's 4b, minus 12, should give us 108. Let's simplify this a little bit now. So 4 cubed, that's 64. And then 64 times 2, that's 128. And 4 square is 16, so that's 16a. And here we have 4b minus 12 equal 108. Alright, and the other hand, we are told that p of negative 4 should give us negative 100. So this time we're going to replace x in the same polynomial, replace x with minus 4, so that's 2 times minus 4 cubed plus a times minus 4 square, and then xb times x, that's minus 4b minus 12 equal negative 100. Let's see if we can simplify this. This is negative 128. That's same 16a minus 4b minus 12 equal to minus 100. So here we have a pair of simultaneous equations. Let's put them together. Let's put them together now and try and solve for a and b. So the first one here, I must rewrite this. So let me call this equation 1. Let me call this equation 2. Alright? So equation 1, let me just rewrite it, restate it. So we are 128 plus 16a plus 4b minus 12 equal to 108. And equation 2, let me restate equation 2. That's minus 128 plus 16a minus 4b minus 12 equal to minus 100. Now you'll notice that we can either add or subtract to eliminate a or b. Now notice b, the signs are different. So if we add, we should eliminate the b. So if we add, let's add. So if we add the two equations, equation 1 and 2, 128 plus minus 128, we end up with 0. 16a and 16a, we end up with 32a. And 4b plus negative 4b, that's 0. And minus 12 and minus 12, I don't keep the sign, that's minus 24. 108 plus minus 100, that's positive 8. So what we can do is add 24 to both sides. So we end up with 32a equal to 8 plus 24, which is 32. Divide both sides by 32. Divide both sides by 32. 32 into itself is 1. So we have a is equal to 32 over 32. So we have a is equal to 1. So of course we can use it to find the value of b. Now we can substitute this value for a in equation 1. So here's equation 1. We can simply replace a with 1. So we end up with 128. If we replace a with 1, 16 times a, that's 16 times 1, which is positive 16, plus 4b minus 12 equal to 108. And we can simply group everything on one side. So we end up with 4b equal to, let's group everything on the right hand, all the constants on the right hand side. We have what now? 108 plus 12 minus 16 minus 128. So we end up with 4b equal to minus 24. And if we divide both sides by 4, b would be equal to negative 6. So the solution A is equal to 1, b equal to negative 6. Part 2. Determine the range of values of x for which 2x squared plus 5x less than or equal to 3 is where x is a real number. Alright? So so we have a quadratic inequality here. So we have 2x squared plus 5x. We're going to group everything on the left hand side. Alright, so we end up with that. Now we can factorize. Notice, let's use the AC method to factorize. So AC, that's 2 times minus 3, that's minus 6. Alright. So what are the pairs of values that multiply to give to negative 6 now, or 6? 6 and 1, and 2 and 3. So notice we need which values either add or subtract to give the middle term. So we can it's be minus 1. So 6 minus 1, notice 6 minus 1 is positive 5, and 6 times minus 1 is minus 6. So we're going to rewrite the middle term as positive 6x minus x, or minus 1x minus 3 less than or equal to 0. So and then we factor by groups. Alright, so factorize the first pair. We end up with the common factor here, that's 2x. So we end up with x plus 3 in the bracket. And the second, we factor out minus 1. And of course, we end up with the same x plus 3 in the bracket. So notice the common factor here in the bracket is x plus 3. On outside, we have positive 2x and minus 1 less than or equal to 0. So notice the critical values here are, the values that makes the bracket 0. So we can equate each bracket to 0 and solve. So the critical values here would be negative 3, and equate 2x minus 1 to 0 and solve. The other critical values here is half. So because it's less than, and the x square, sorry, this is x square, that's x cubed. The x square coefficient here is positive and it's less than. So the solution lies between the two critical values. Alright, the larger value is half, the smaller value there is negative 3. Alright, so that's our solution. Question 2. Alright, question 2, we can simply multiply both sides here by the denominator, just to get rid of the denominator. Multiply both sides by 4 to the power of 3x, or we say cross multiply. We end up with 2 to the power of 2x plus 1 equal to 4 to the power of 3x. So we'll now try to write both of them to the smaller base here, base 2. So we restate 2 to the power of 2x plus 1. And 4, we can rewrite 4. Remember, 4 is 2 square. So it's 4. Rewrite the 4 as 2 square. And don't forget the 2 to the power, the 3x power there. So this becomes 2 to the power of 2x plus 1. And the last indices, we can just take the product of the powers here. So 2 times 3x, that's 6x. Now, since the bases are the same, we can therefore equate the powers here. So we end up with 2x plus 1 equal to 6x. And we can solve this. All right, let me just subtract 2x from both sides. If I subtract 2x from both sides, I'll end up with 4x equal to 1. I'm solving for x, so I divide both sides by 4. So x is equal to a quarter, or 0.25. Part B, given that f of x equal to negative 2x plus 3 and g of x is equal to that, determine f of x minus g of x. So f of x, that's minus 2x plus 3. Subtract g of x. What's g of x now? Minus 18x squared minus 13. So the bracket is very important. There is minus all of g of x. So we end up with minus 2x plus 3. We can distribute this negative. Think of it as negative 1 outside there. So we distribute negative 1. We end up with positive 18x squared plus 13. We can group like terms. Now let me put the x squared first. So we have 18x squared. We have minus 2x. And if we group the constants, 3 and 13, we end up with 16. Now the second part, we are asked to solve the composite function fg of x is equal to 173. So let's find fg and equate it to 170. Now fg is f of, now what is g? G is minus 18x squared minus 13 equal 173. So we're going to put g in f. So in f, the function here, we're going to replace x with whatever is in the bracket. So we're going to replace the x with, what's the bracket here? Minus 18x squared minus 13. And remember, we have to put back a positive 3, right? And that's equal to 173. So let's solve this. So we can expand the bracket. So minus 2 times each term in the bracket. So minus 2 times minus 18x squared. We end up with 36x squared. And minus 2 times minus 3, that's positive 26 plus 3 equal to 173. So let's group all the constants here on the right hand side. So we have that with 36x squared equal to 173 minus 26 minus 3, right? So we end up with 36x squared equal to 144. Divide both sides by 36. So x squared is equal to 4, which means that x is equal to positive 2 or negative 2. So we're on to part C. A GP is such that the seventh term is 8 times the fourth. So the seventh term is equal to 8 times the fourth term. All right. Now for a G, no, we're also told that the fifth term is 48. So the fifth term is equal to 48. All right. Now what's the fifth term for a GP? Remember for GP, the formula AN is equal to AR to the n minus 1. So if we're talking about the fifth term, we replace a with 5. So the fifth term is given as ar to the power of 4. So ar to the power of 4 is 48. And the seventh term would be, you replace n with 7. So that's ar to the power of 6 equal 8 times the fourth term. And to get the fourth term, replace n with 4. So it's ar cube, 4 minus 1, 3. So we can form those two equations. That should help us to get the common ratio. R. So what we can do here is divide both sides here by ar cube. So divide by ar cube. Divide by ar cube. So ar cube into itself. So will leave us with 8. So a into a, that's cancel. So r to the power 6 divided by r cube, that's r cube. And if we take the cube root of both sides, r is equal to 2. Now what we can do is substitute r equal to 2 into this equation here. If r is 2, we can substitute it into this. So we end up with a times r to the power 4. So a times 2 to the power 4 equal to 48. Now 2 to the power 4 is 16. So we end up with 16a is equal to 48. And to get a, we can divide both sides by 16. So if we divide both sides by 16, a is equal to 48 divided by 16, which is 3. Now the first term is what we call a. R is what we call the common ratio. That's that. Part D. So we have a log equation here. We're asked to express log 65 over 27 base x in terms of a and b. Now this problem requires us to know some of the rules of logarithm. One of the rules of logarithm is that put one of the rules up here. Log a over b is equal to log a minus log b. Alright? So we can apply that rule there to this. So from here, the base we are using here is x. So here, notice everything is base x, so we don't have to worry about what the base is. So here, log 625 over 27. So the a would be the numerator there, like this minus log of the denominator. And the same way we have this rule here. Notice log of the numerator here a minus log of the denominator here, which is b. So that's the rule we applied here. Let's know. So log a base x. So sorry, we're not putting a, we put in 625, right? So log of the numerator minus log of the denominator here. No. No, log 625. No, 625. No, 625 is same as so let me rewrite. So 625 is same as 5 to the power 4. And 27, we can rewrite 27 as 3 cubed. Alright? Now there's also another rule of log that says that we can, the power here, we can put the power at the front here. So 4 log 5 minus, we can put the power here, 3 log 3. There's also another rule of logs that says, if you log a term, this is log a to a power there, n, then this is equal to n log a. Alright, so the power here, we can move it back and forth to the front or to the power here. Now we know that log 5 is b and log 3 is a. Alright, so log 5, that's b, so that's 4b. And we know that log 3 is a, so that's 3a. So that's it. We have a trigonometric equation here. All right. Let's solve. So, what can we do here now? Let me just put the tan x on the right hand side. So we have root 2 equal to 2 tan x. So we want tan x by itself, so we can divide both sides by 2. So root 2 over 2 is equal to tan x. And now to get x, we can use our calculator. Now x will be equal to tan inverse root 2 over 2. And this is something we can use our calculator to do. And I'm getting the primary angle here to be using 2 decimal places. I'm getting the primary angle here to be 35.26 degrees. But remember, between 0 and 360, 2 of the angles are positive for tan. So remember, all science teachers are crazy. Alright, so in the first quadrant, tan of all the angles give us a positive values. Well, whether it's sine, cos, or tan, the angle you get a positive value for the angle. So tan is positive for between, so this is 0 and 360. This is 90, 180 degrees, 270 degrees. So tan is also positive in the, so all are positive in the first quadrant. Tan is also positive in the third quadrant. So to get the angle in the third quadrant, we just add it to the horizontal 180. So the other angle would be 180 plus 35.26 degrees, and that will give us 215. So x equal to 215.26 degrees. So these are the two angles that would satisfy this equation.